Okay, so today we're going to be talking about graphing our sine and cosine. You're like, wait a minute. Didn't we kind of already deal with sine and cosine? And the answer is, of course you did. However, when we graphed it before, we talked about a unit circle, which is really graphing the equation x squared plus y squared equals 1. What do you mean, woman? Well, look, when we graphed a circle, we really had a radius of 1 is called a unit circle. And all we talked about is as you go to different points on that circle, there's infinitely many points. We focused on the points where the angle formed between the x-axis was going to be something special. Okay, and so we said, okay, well, let's draw a 30-degree triangle, and that point on the circle that makes this equation true was going to be the point, the square root of 3 over 2 for x, and the value for a half was y. And we talked about, because x is going to be cosine over 1 and y was going to be sine over 1, we talked about looking at those ordered pairs in combination with the angle formed with the x-axis and saying we can read according to the circle graph, the ordered pair on the circle demonstrates the Pythagorean identity, the trigonometric Pythagorean identity, but it also shows us sine and cosine. And if you looked at this a little more carefully, the value for sine is going to be the y-coordinate, okay? And so notice as you increase the angle, the value of sine gets a little bit bigger as you increase the angle it makes with the x-axis. So if it's the y-coordinate, as you open the angle, the y-coordinate gets a skosh bigger. And so at 45 degrees, the y-coordinate will now be the square root of 2 over 2, which is a smidge bigger than a half. And then if you furthermore make it at 60 degrees, the y-coordinate, which is the sine, is going to be actually the square root of 3 over 2. So as you increase the angle, the value of sine is changing. In fact, the biggest that sine can be is going to be 1. At 90 degrees, the value for sine is actually 1. Does sine ever get bigger than 1? No. What's the smallest that sine can be? Well, it's -1. Okay, so it fluctuates between the value of -1 and +1, and it goes through all the values in between. And so if we choose to not graph the unit circle, but to actually graph an input of an angle and the output being the value of sine. So, you could technically plug different angles into your calculator and be like, oh, let's do the sine of 40 degrees or 45 degrees or 47 degrees. As you increase the angle up to 90 degrees, the value for sine is going to be increasing, okay? The value for sine at 0 is going to be, maybe 1, 0. So the value for sine at 0 degrees is actually 0. And so if we graph the value of sine for increasing values of theta, you're going to see the value of sine change. Okay, and it'll fluctuate between 0 or from -1 up to +1. And so it'll repeat because the value of sine, as you go through the unit circle over and over again, will fluctuate every 2 pi or every 360 degrees. It'll rotate those values again. So let's practice graphing some of these values. Okay, so if you look at the domain would be any real number. You could plug in any angle and find the value of sine. The range, though, of the values for sine is going to be from -1 up to +1, and you'll see that there. And the same for cosine. Cosine is just the adjacent leg, and it goes from -1 up to +1. That's going to be the range. There's a symmetry, okay? And then also if we just say, okay, well, let's just graph it using our mind. Okay, we could pull out our unit circle and say, okay, let's find the value of sine at those specific values. And so if you go to your unit circle and say, okay, at 0, okay, 0 degrees, what is going to be the value for sine? And that's going to be 0. Okay. At 90 degrees or pi over 2, again, we could do pi over 4, we could do all sorts of things. But at pi over 2, at 90 degrees, what's the value for sine? It's going to be 1. At 180 degrees or pi, the value for sine is going to be 0 again. At 3 pi over 2, the value for sine is -1, and then 2 pi, it's back to 0. So the values are going to fluctuate. It's called a sine wave because it kind of looks like hills and valleys. Is going to start at 0 for 0. At 90 degrees, the value is going to be 1. So let's call this 1 up here. At pi, it's going to be 0 again. This is going to be -1, and this is going to be pi. So it's going to be a repeated, okay, a cyclical function. So it's going to go over and over again because as you go around the unit circle multiple times, it's going to keep repeating the values for sine. Every 2 pi, it'll repeat that cycle. So it's like a hill then a valley. Okay, so it starts at 0, goes up to 1, goes back to 0, goes down to -1, and goes back to 0. And then it will do it again if you go around the circle again. It's really fun. So the value of cosine, again, that's the adjacent leg. And so let's do the x coordinate at each of these points. The value of cosine at 0 is going to be 1. At 90 degrees, the value of cosine is 0. Then it's going to be -1, and then 0, and then 1 again. So cosine starts high at 1, and then it goes to 0, and then it goes at pi, it's -1, and that's going to be, and it should hook over, okay? If you're staying in class, I'm going to do kind of a Karate Kid move. Oh yeah, it's real cute. Because I want you guys to be able to graph, oh dear heavens, what's going on here? Okay, let's see if I can get this to go. Oh dear. I want everything to go with me, but I'm not sure if I can make that go. And so we want to have this go up to 1 here. Okay, so it's going to kind of hook over the end there. Okay, so put your hands up like a Karate Kid, and they're going to hang over, like loop over. And so it's going to be the same shape. It's going to be shifted left to right because the values for cosine will be the legs, but it'll be the opposite leg. I mean, the adjacent leg, but it will be the different leg compared to cosine or sine. And so I'm just going to have to get out of this thing because it's kind of ridiculous. What's going on here? Okay. So now we're going to do transformations like you've done in all the other chapters that we're going to do. And I think the big thing would be, if you do sine, you know it's a hill then a valley, okay? If you do cosine, it's going to be high, low, high. And I'll demonstrate what that looks like in class. But I think the big thing would be you can actually find the sine of certain angles and then double their value. That's going to be a vertical stretch by a factor of 2, okay? And so every hill will be higher, every valley will be lower, twice as much. So normally sine starts at 1, okay, starts at 0 and it goes to 1 and goes to 0, goes to -1 and goes to 0 again. But when you have double that, well, double 0 is still 0, but double 1 is going to be 2 and then 0 and then -2 and then 0. What do you mean? Well, watch this. Every cycle has, it starts at 0 for sine, normally goes up to 1, but it's going to go up to 2. So it's going to go from 0 up to 2, back to 0, down to -2, and then back to 0. So it's a vertical stretch by a factor of 2. Now you can put any coefficient in front of sine and it'll be the same shape, but it'll be a vertical stretch. Okay, you could put a half in front of it and it's going to be a vertical compression. So instead of going from 0 up to 2, it'd be 0 up to a half. And so we will notice that with cosine. So sine is a hill then a valley. Okay, 0, 1, 0, -1, 0. And there are 5 values, and it starts at 0 and goes to 90 degrees or pi over 2, then pi, and then 3 pi over 2. And by the time it's to 2 pi, it's going to have done that cycle. And then it will repeat itself again. So cosine, again, starts at high. Normally it's going to be 1, 0, -1, 0, 1. But when you have a vertical compression by a half, the amplitude, you've got waves. If it's a real strong storm, the waves will be quite a bit higher and lower than normal. But if you've got a very calm wind, the waves will be even smaller. And so if it's going to be a vertical compression by a half, then that means instead of starting at 1, it's going to start at a half. So you're going to start at, let me change these to be a half, and then still 0, and then negative a half, and then 0, and then a half. And so you're going to start at a half. 1, 2, 3, 4, 5. So it's going to be to 0, down to negative a half, back to 0, and then up at the top. Okay, so swing that like this. And so it'll repeat, but the x values are going to start at 0, and it's going to be pi over 2. It's going to be pi, which is 180, and then 3 pi over 2, and then 2 pi. And then it'll start over again. Okay, so it's going to start high, medium, low, medium, high, medium, low, medium, high, and that'll be cosine's shape. Now, if normally the graph for sine is a hill, then a valley, starting at 0, and it goes up a hill, down a hill, low valley, and then back to normal. The negative sign is going to be a vertical reflection, okay? So it's going to reflect across the x-axis. And you notice that gives it a valley, then a hill, okay? And same with cosine. If cosine normally goes high, medium, low, medium, high, well, then reflecting it across the x-axis is going to start low and do the vertical reflection of it. So you can do a vertical stretch or compression of either graph. You can do a vertical reflection of either graph by slapping a coefficient of a negative in front of it. And then the period, you know that if we're on block day, the time period is an hour and a half. If it's a half day, the time period is like 20 minutes, and so if it's a normal period, you get like 48 minutes or something. So we can change that by changing the value in front of x, the horizontal compression or stretch. Okay, so we can stretch it horizontally or compress it. Now, I think the first thing is normally the time period is going to be 2 pi. To accomplish that. Okay, 1 lap around the circle. However, if you can stretch it longer or shorter, okay, depending if you're trying to get through the cycle faster or shorter, okay, if it's a block day or a half day or whatever. And so to find out the normal period, the period that it's going to be is you take 2 pi, okay, the normal time period, okay, to go around the circle is going to be 2 pi, and you put it over b, okay? So the b is the coefficient in front of the x, okay? And so the coefficient in front of x, okay? So normally it would be cosine of x or cosine of theta, if you want to call it theta. But if you take 2 pi over that coefficient, that will take care of, well, how long does it take to get through that period, okay? And so let's keep trucking through this. So let me see what we've got. Switch this. Okay, so side 2. Okay, so if we're going to be sketching this, okay, I spy that it's going to be a vertical stretch by 2, okay, vertical stretch by 2. And then I also see that there's something going on with the coefficient of x, okay? Do you see how it's like a half x? And so if you do 2 pi over a half, okay, so it's a half in front of x, then you're going to get 4 pi. Is going to be the period. Okay, so 4 pi is the period. So normally it's going to be a horizontal stretch by 2. What do you mean, woman? Well, because if you see normally, you're like, excuse me, if you're doing like 1/2 and then x and then squared, it's a horizontal stretch by 2. That means it's twice as wide as normal, right? Well, this has a 1/2 in front of x. It's going to be stretched horizontally twice as long. So instead of taking 2 pi to get through the cycle, it's going to take 4 pi, okay, to get through the cycle. So the time period it will take will be twice as long, or 4 pi. And so And now it's not scooched left to right. Okay, you would notice that if there's something added or subtracted to the x, it's not scooched up or down, so that'd be something added or subtracted to the function, but there is a vertical stretch. So the amplitude would be plus or minus 2 from the midline. So you always start with like a vertical line and be like, okay, this is 0. And instead of going plus or minus 1, let's label it, say it's going to go plus or minus 2. Okay. And so it is cosine. Okay. And so we are going to start at the high value of 2. And then it's going to go high, medium, low to the low value, back to medium, and then high. And we're going to lump our hands over it like a karate kid. Now, the thing is, we got to figure out, how do we label these x values? Okay, we know that it starts at 2 and goes to middle and goes to low, goes to middle, goes to high. But how do we label these values? Okay, the phase shift is left or right. There is none. And there's no shifting up and down, so that we'd write none. Okay, so there's nothing added or subtracted to x. There's nothing added or subtracted to the function to lift or lower the graph. Kind of like a high tide or a low tide might be. And so we've got to just label these values. And so to label these values, there's a couple ways. One, you can just know it and do it. Okay. Another way is to say, okay, I know if I take the period that I'm going to do for this graph, and I'm going to put it over, you put period over 4. Okay, so you divide it into 4 pieces because there's 4 basically adjustments, 4 marks after that initial part. So what do you mean, woman? So you're starting at 0 and you have to count 1, 2, 3, 4 until you're done with the cycle. So you basically take the time period it's going to take to do this and divide it into 4 pieces. And so it's like we've got an hour and we're going to divide it into 4 different tasks. Okay, so and so that's how you count. To get the count, you're going to take the period and divide it by 4. So the period for this graph is going to be 4 pi. And if you divide it by 4, you're going to get pi. So that means from the starting x value, you just add pi each time, and that's going to be what you're going to do. Now, sometimes you're going to have to add a fraction. You're going to have to be very brave. But in this case, we're adding pi to 0. And you're like, okay, well, that means this first one's pi. Add pi again, you get 2 pi. Add pi the third time, you get 3 pi, and then you get 4 pi. And so from 0 to 4 pi, we've done the shape of cosine, okay? And so you should label your x-axis and label your y values, okay? And so, yeah, it tells you that. Divide the period into 4 equal sections and then follow the pattern of the sine of the cosine graph. Well, the next one's going to be a sine. And so you know sine is a hill then a valley. And so let's see what we've got. We've got an amplitude of a half, okay? A is the coefficient in front of x. That means it's a vertical compression by 1/2 if we're talking about the transformations. Now we also have a horizontal stretch or compression. So to find that, we're going to do the period that's normal, okay, and divide it by this b right here. So we're going to take 2 pi and put it over 8. So the period is going to be pi over 4. So that means that the whole thing is going to get done really fast, okay, by pi over 4. There is no shift left to right because there's nothing added or subtracted to the graph, okay? This technically could be called a horizontal compression by 1/8, okay? It's going to get done really fast, okay? It's kind of like the fastest, school day you could ever come up with. So from start to finish, we're going to be done by pi over 4. Isn't that weird? And so, and it's not shifted left to right. So if you start at 0, you're going to be done by pi over 4. So you divide it in half and then half and then half again. Okay, so from start to finish, you go half, half, and half. Now, sometimes people struggle with knowing how to count. Okay, there's no shift left to right because there's nothing added or subtracted to x. There's no shift up or down because there's nothing added or subtracted to the function. So the question is, how in the world, okay, are we going to actually count this out? So to find the count, okay, so do the count, you do the period divided by 4. So the period of this graph, okay, is going to be pi over 4. We're going to divide it by 4. Okay, so you do pi over 4, and then you times it by 1/4, Okay, because remember, divide, you flip over the bottom thing, so it'd be pi over 16. So we're going to count by pi over 16. So we're going to start with the beginning value. We're going to add pi over 16 each time. So this is pi over 16. If you add pi over 16 to that, you get 2 pi over 16. If you add pi over 16 to that, you get 3 pi over 16. And if you add pi over that, you get 4 pi over 16. Well, 4 pi over 16 really is a fourth pi. So we did a good job. And then we have to draw a cosine or a sine. So a sine starts at 0, middle, high, middle, low, middle. It's going to be a hill and then a valley. And it's going to be back to normal. And so that's going to be the value, the graph of sine. That's going to be vertically compressed by half. So notice the amplitude is plus or minus a half from the midline, and it's horizontally compressed by 1/8. Notice the whole thing gets done very fast. Within, actually pi over 4, within 45 degrees, the whole thing is done. Okay, so it's like dun, 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 done. So we're doing transformations. We're graphing sine and cosine, and we're trying to be very careful as we do that. Okay, I'm going to shift this up. Okay, number 5 is a vertical stretch by 3. Okay, so the amplitude will be plus or minus 3. The period, there's going to be a horizontal something going on here. So to find the period, you do the normal period for that graph, which is 2 pi, and you put it over that coefficient. So if you do 2 pi over 4, you're going to do 2 pi times 4, which is going to be 8 pi. So that's going to be elongated. It's like the longest day ever. So the time period it's going to take is 8 pi from start to finish. Okay. Now it's not shifted left to right because there's nothing added or subtracted for x. There's nothing shift. The whole graph is not shifted up or down. So that's going to be a vertical shift of nothing. So it starts at 0. To figure out how to count, to label your x-axis. Okay. Again, it's going to be plus or minus 3 on the y-axis. Okay, we're going to do sine, so it's going to be a hill then a valley. To do the count, okay, so you know how to like label these x-axis from your starting point. You're going to do the period for this graph, so it's 8 pi, and you put over 4, so that gives you 2 pi. So every time you move here, you add 2 pi to where you started with. So your x-axis, your first value is 0. Add 2 pi, you get 2 pi. Add a 2 pi again, you get 4 pi. And you get 6 pi, and then you're going to have 8 pi. So from start to finish, it takes 8 pi to get the whole thing done. So you're going to graph sine, which is a hill, then a valley. So middle, high, middle, low, middle. Your amplitude is plus or minus 3. And that's your graph. And so there's a couple x-intercepts. And the domain is all real numbers, okay? The range is going to be from plus or minus 1, okay, from -1 up to infinity. Now, here's kind of a fancy way to do it, but we don't really have to get all that involved. I think the big thing is the coefficient in front of it is going to be a vertical stretch or compression. If it's negative, it's going to be a reflection in front of the function. So this is going to be, if we want to write out what's going on, we're just going to say it's a vertical stretch by 2, reflect vertically across the x-axis, and it's going to be a horizontal compression by 1/4. So it's going to take a very short time to get this done, okay? It's going to be 2 pi over 4. So the whole graph, the whole cycle is going to occur within pi over 2, okay, within 90 degrees, which is crazy. The second graph is going to be a horizontal stretch by 2. So if you do 2 pi over a half, I don't know what I'm writing here. 2 pi over a half is going to be 4 pi. So instead of taking 2 pi to get the graph done, it's going to take 4 pi, twice as long. The third one is going to go right pi over 2. So it's going to start a little late, and it's going to be up 4. And it's going to be a vertical stretch by 3. So the amplitude will be 3. It'll be kind of like a high tide, because so your horizontal line is going to be up 4, and it's going to be right pi over 2. So it's kind of a weird thing. So we're going to talk about shifting things right now, okay? So you know add or subtract x is going to change that. So let's see if we can graph some of these things. Okay, the first one we talk about is going to be an amplitude of 5. Okay, so it's a vertical stretch by 5. It's going to be down 3. Did you see that? Okay, so it's going to be down 3. Okay, so when we go to graph this, it's a vertical, the amplitude is plus or minus 5 from the midline, but the midline is actually down 3. So you're going to draw at -3, kind of this. It's kind of like you're graphing the ocean at low tide. Okay, and so this is the midline is at -3. And from here, you're going to plus or minus 5. So if you go up 5, so 1, 2, 3, 4, 5, this is going to be at 2. And if you go down 5 from here, you're going to be at -8. Okay, and it's cosine, so it starts at the highest point. Okay, so you're going to go out, you're going to go half, half, and half. Okay, so you got 4 more points after the beginning value. It's not scooched left to right. So it's going to start at 0, but it's going to start at the highest point, which is going to be at 2. It's going to go to the middle point. It's going to go to the lowest point, middle point, and then the highest point as well. Okay, so if we graph this as cosine, we just have to label our x-axis, okay, to be like, okay, we know it's going to be high, low, high, medium, low, medium, high, because it's cosine. It's going to be down 3 overall. It's plus or minus 5 from that midline, okay? And then the period, if we're talking about, it's going to be horizontally compressed by half, because remember, you do the reciprocal of what you see there. So if it's horizontally compressed by half, to find the actual period, you're going to do 2 pi, the normal period, and put it over b, which is going to be pi. So the period is going to be pi. So it's going to be half as long as normal. Okay, horizontal compression by half. Okay, so the time period is going to be pi. There's nothing shifted left to right. However, it is going to be down 3. Okay, that's the -3. So let's label this. So to label it, one way to do it is to find the count and say, okay, I'm going to count the x's by that counting value. So you take, to find the count, you do the period divided by 4. So the period for this one is going to be pi, and you put over 4. So you're going to count by pi over 4 each time. So if you add 0, which is the starting x value, add pi over 4 each time, you get pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4. And notice from start to finish, it takes pi. Okay, so we're done by pi over 4, 4 pi over 4, which is pi. So that's going to be the graph of this function here. So we can have shifts vertically. We can have a horizontal stretch or compression. We can do all sorts of things. Okay, so let's look at our next picture. Okay, this next one is going to be sine, okay? It's going to be a vertical stretch by 2, okay? So the amplitude is going to be plus or minus 2. Okay, and the period is going to be, it's weird because they put a pi here. That doesn't normally happen. It makes it cuter and a little bit weird, just heads up. Okay, so to find the period, you go the normal period, which is 2 pi, and you put it over b, which is pi in this case. So it's going to take 2. 2 what? Just 2. And so you're going to go longest, middle, half, and half. The period is going to be 2 units, okay? And so the amplitude is 2. The period is going to be 2 as well. The phase shift, there's nothing shifted left to right, okay? It doesn't start late or early, and it's not going to be shifted up or down, okay? And so the amplitude is plus or minus 2, and it's sine, okay? Now it's reflected, so you be careful. Instead of doing a hill then a valley, for sine, if it's reflected vertically, it's not going to do this. It's going to do down here, a valley, and then it's going to do a hill. Okay, so reflecting vertically will make it look like this. And so the amplitude is plus or minus 2. It's not shifted left to right. The time period is pi. Okay, so let's figure out how to count. So you take the period and you divide it by 4. So the count is by a half. Okay, so you're going to add x is 0, add a half. You're going to add a half again, so that's going to be 1. This is 3/2, and this is going to be 2. And so it's kind of weird how you count. It's more fun when you count by radians or by degrees, but this is going to be by units. And if you plug in those values, it would make it true. It's just kind of weird when it's in terms of pi. So let's scooch this up and let's go back to kind of a more normal one. Okay, so this next one has an amplitude just of 1. There's no vertical stretch or compression. The period is going to be 2 pi over 3. Okay, the phase shift, there is no shift left to right. The vertical shift is going to be up 3. So let's do this. Go up 3. Okay, it's going to be like high tide now, and draw a horizontal line. And then it's going to be a period is 2 pi over 3. So let's figure out how to count. Okay, so we're going to go to the end, the middle, okay, so we're going to do, to count, we're going to take the period, which is 2 pi over 3. We're going to divide it by 4, okay, or times by 1/4. So you're going to get 2 pi over 12 or pi over 6. So that's how you're going to count. So from here, you're going to go to pi over 6. You're going to add that to your initial x value. So pi over 6, 2 pi over 6, 3 pi over 6, and 4 pi over 6. And notice from start to finish, you go from 0 up to 2 pi over 3. And so if you minus the starting and ending point, you're going to figure out how long it takes to do that period. So it's going to be 2 pi over 3. If you minus 0 and 4 pi over 6, your amplitude is just going to be plus or minus 1 from the midline. And it's cosine, so we're going to go high, medium, low, medium, high. I'm going to graph it. Okay, and it will repeat as time happens. Okay, so there you go. It's cosine with horizontally compressed by 3/2. Okay, so normally it takes a period of 2 pi to get this done. So it's horizontally compressed by 1/3. It's a third of what it normally is. Okay, because 2 pi over 3 is kind of short to be done with this cycle. And so you can see that that's what happened here. Let's keep trucking. I got just a couple more. This next one is going to be a vertical stretch by 3. It's going to be down 1. Okay, so vertical shift down 1. Phase shift, there's nothing added or subtracted to x, so there's no shift left to right. It doesn't go early or late. The period is going to be 2 pi over 1/3. So if you take 2 pi over 1/3, you're going to get 6 pi. So it's going to be horizontally stretched by a factor of 3. So it's 3 times as long. Notice it takes 6 pi instead of 3 pi to get it done. So you're going to start at 0, and you go to the end, the middle, and halvesies each way. It's going to be down 1, so that's going to be our midline. And from that midline, the amplitude will be plus or minus 3. So let's go up 1, 2, 3. So that's 2 and down 3 to -4. And it's sine, so it's going to be middle, highest, middle, lowest, middle. It's going to be a hill, then a valley. We just have to label our x values. Okay, so we're starting at 0. So to find our count, we take the period over 4. So the period of this one is 6 pi, and you put it over 4. Well, that's 3 pi over 2. So from your initial x coordinate, which is x, you're going to add 3 pi over 2. So you add 3 pi over 2 and add 3 pi again over 2. So that's 6 pi over 2. Add 3 pi over again, you get 9 pi over 2. And then you get 12 pi over 2. So notice from start to finish, you do get done in 6 pi. Okay, so that's the transformations. All right. Now, I think the last couple questions the last 2 questions we're going to talk about are going to be when you shift it left to right. Okay, so if you're going to try to catch a wave, you're going to have to make sure you wait till it starts. You want to catch it at the upper part, otherwise you get drowned. And so there's a couple ways to do this, and I'm going to teach you kind of how to look at this. This is a vertical stretch by 2. So the amplitude would be plus or minus 2 from the midline. It's not up or down. And the period is going to be 2 pi over 1, which is just 2 pi. Okay, the coefficient in front of x is just 1, so it's just 2 pi. It's going to be right pi. Okay, there's no up or down shift, so it's 0. Okay, so it's going to start a little late. Okay, we're going to start at pi. And so you're like, okay, I could have it start at pi and then make the shift. Well, you want to count from 0 appropriately. Okay, and so I know it's going to start at pi, and then it's going to make its traditional sine shape. Okay, with an amplitude of 2, and you're going to be set. Okay, so let's think about this. Okay, I think the big thing is a lot of kids struggle with this. And so we normally, when you graph a sine or cosine wave, the beginning is at 0, the ending, the whole wave is done by pi over 2 or 2 pi. And so what I would suggest for the harder questions that you struggle with is take the parenthesis and set it equal to the normal start and the normal finish so you know when to start and end. So take the parenthesis and set it equal to 0. That's the normal beginning value for your hill, your valley, your hill and valley, okay? And so you do x minus pi and set it equal to 0 and solve for x. If you add pi to both sides, you get x is equal to pi. So that's where you're going to start. And then if you take the parentheses, x minus pi, and you set it equal to 2 pi, the normal end of this, okay, you're going to add pi. You're going to get x is equal to 3 pi. So our new cycle will start at pi and go to 2 pi. It hasn't changed horizontally like stretch or compress. So notice if you minus the start and end, you still get 2 pi. So that will be the normal time length. Okay. It's kind of like a late start. Okay. It starts a smidge late, but it still does the same thing as a normal block day. And then we got to figure out how to count. Well, you take the period, which is 2 pi, and you put it over 4 because you're divided into 4 increments. So you get pi over 2. So from where you start, which is going to be pi, okay, you're going to count by adding pi over 2. So you're going to do this half, 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 okay? And so you're going to be like, how do I even count? Okay, so if your initial value is at pi, okay, then you're going to say, okay, I'm going to add pi over 2 each time. Okay, so pi, so you can get a common denominator. That'd be a good idea. So pi is 2 pi over 2. Okay, if you want to call it that, 2 pi over 2, which is pi. Add pi over 2 to it, you get 3 pi over 2. Add pi over 2 to it again, you get 4 pi over 2. If you add pi to it again, you get 5 pi over 2, and then 2, and then 6 pi over 2. So it starts at pi and ends by 3 pi, or it starts at pi and ends at 3 pi. So it's going to be doing the same length, but it's just going to be starting a little late. Okay, and so we're going to start at pi. Okay, and it's sine, so it's going to start not up and down. Okay, it's going to start here. It's going to go to the top, middle, down again, and then back to the middle. So it's the sine wave, the classic sine wave with a vertical stretch of 2. And there's no horizontal stretch or compression. It still gets done in 2 pi, but it's late start. It starts at pi, okay, and it ends up by 3, or starts at pi, ends by 3 pi. And so to get that starting ending point, set the parenthesis equal to the normal start, which is 0, and the normal end, which is 2 pi, and solve for those beginning and ending x coordinates. Okay. And then if you look at, I think we just have one more left. Okay. This one is going to be an amplitude of 3, and then the period, and it's going to be reflected vertically. And the period is going to be 2 pi over 1, which is just 2 pi. Phase shift is going to be left pi over 2, okay, and nothing vertically shifted. Okay, so normally you start at 0. We're going to start a little early at negative pi over 2. And we're going to finish at some point. Okay, so we got to be like, how are we going to set this up? So we set the parenthesis, okay. Okay, so to figure out when you start and end, okay, you're going to set the parentheses equal to the normal start and finish. So x plus pi over 2 normally starts at 0. So if you solve for x, you get negative pi over 2, which we knew. We're going to start a little early. We're going to start at negative pi over 2. And if you set the parenthesis equal to the normal end, which is 2 pi, and you subtract pi over 2 from that, get yourself a common denominator. The common denominator would be over 2, so it would be 4 pi over 2 minus pi over 2 is 3 pi over 2. So everything's going to be done by 3 pi over 2. So 3 pi over 2. And so I think the big thing would be, the count. We'll take the period, which is 2 pi, and divide it into 4 groups. You're going to add pi over 2 to your beginning value. So again, that makes sense. Take negative pi over 2, add pi over 2 to it, you get to 0. Add pi over 2, you get pi over 2. You get 2 pi over 2, and you end by 3 pi over 2. If you minus 3 pi over 2 minus a negative pi over 2, you're going to get 4 pi over 2, which is going to be 2 pi. So there's no stretch or compression. The whole thing gets done in the same time period. You just start a little early. Okay. So it's like an early start. So you can be early release. And so we're going to graph cosine. The amplitude is plus or minus -3 or plus or minus 3. But because it's cosine that's reflected, instead of starting high and going to the middle and then being low and then the middle and the high, it's going to do the opposite. It's going to start at the lowest value, go to the middle, highest value, middle, and then lowest value. Let's graph this. Okay, so the amplitude is 3. There's no up and down movement. There's a left movement of starting at negative pi over 2. And the count will be adding pi over 2 each time. So that's what our graph will look like. So the domain, it depends on the amplitude. The range is going to be all real numbers because it's going to go forever repeating. But this is kind of a start on how do you graph sine and cosine.